Okay, welcome back to another tutorial. So here I'm like trying to do a flow simulation, and for that one I have a parametric study. And for that parametric study I have been like trying to do that to change the cat. Of course I have to hide my cat because it is a super secret right now. Later I will release all the things, but for now uh, let's keep the cat out of the situation, and I will show you what's going on. So here what I did is like to avoid the singularity issues. I don't know, I tried it in different ways, but sometimes like the geometry tends to change. Like SolidWorks likes to define angles between 0 and 180, and if it is going beyond that, I think it's going to wrap around from the other side and give us an acute angle or something. And in between the configuration of the flow simulation, it tends to flip the rotations, and everything tries to get messed up. So north east down frames coordinate systems, I have several of them. So here and here I just have dummy parts for each rotation. So I put the dummy parts into an assembly and secure them with the main. So this is a dummy part that I designed. It's basically a sketch. That sketch is added to an assembly to give me the yaw rotation. Similarly, I have another sketch which is also a dummy part that gives me the pitch rotation. So everything is mated to the origin. So in that way, like I can rotate like around this point, but the dummy parts are used for each axis. So pitch dummy is also there. So pitch dummy, what did I just do? Okay, you know that save, cancel, let's cancel. What's going on? Exit preview. Okay, so pitch dummy part is also here. So that is also northeast down frame. I just want to keep them in that way because like that is the normal aerodynamic coordinate system that I want in my simulation. So let me show you what I have right now. Okay, so I don't know whether it's going to work. I tried different ways. I tried to do it in several ways, but this keeps giving me a headache. So see, the yaw rotation is, I always define the angle by using an obtuse angle, because we cannot use acute angles because we need the simulation to vary the pitch or the angle between 0 to plus 90 and minus 90 for the yaw, as well as for the pitch it's also positive 90 to minus 90, so covering the entire flight envelope and giving us the full aerodynamic range. And we don't need to have the roll because when we have yaw and pitch combinations, all the roll rotations will also be covered, so I can easily extract the forces, x, y and z forces, as well as like the torques around torque, I mean the pitching moment, rolling moment and the yawing moment. That is like I have that coordinate system fixed to my CAD model, right? For the CAD model I have that, and all the other things I will be like having the flow always flowing at negative x direction in the global coordinate frame, so that I can extract lift drag directly. I will be measuring those forces in that coordinate frame. So let me show you what I have here. So I added some equations here. Those equations will be used to govern the rotations, right? Right now it's like this. Let me like manage the equations and show you what's going on. So right now there's but did I hide? No, right? So yo, let's put the yo to be, I did not add the equation for the yo yet. Anyway, let's do the pitch, right? So I'm here, it's only pitch 10 degrees. So can you see now we have a pitch of 10 degrees, and here once I like parameterize the study and get it to work, it will have this kind of a setup, right? So 30. And also like in case like I will be doing the simulations in steps of 10 degrees, so I don't want to hit 180, because when I did it for like couple of days and try to like do this over and over again in different ways, I think that we have a singularity issue with the mates. So don't think it is like supported or something like that. So if I put because this mapping is from minus 90 to 90, so if I put 90, I will like limit that to this is like I don't want to go to 0, so I just have 0.1. So you need to have some kind of a limit like that, otherwise we cannot do this, right? So and also this is like 90 means like it will be zero point 0.1, so it is like 0.1 degrees of, so it will be actually instead of 90 it will be 89.9, right? And if we go minus 90, the same situation. So minus 90 means again we are limiting at minus 89.9. I hope that this will clear the singularity issue. All the other angles like we can vary, and I need to do something similar for the yaw, and let's see whether this time it will work. So let's see what happens. Yeah, that's what I'm doing right now.